When a current passes through a straight wire, we know that the magnetic field lines are circular in shape and that the direction of these field lines, that is whether they are clockwise or anti-clockwise, depends on the direction of the current. Now, if we were to twist this wire a little bit, say in the shape of a square, if the current was flowing across the loop like this, we can say that the magnetic field lines for AB will look like this, for BC will look like this, and so on, using a right hand rule. Here, each small part of the square wire can be thought of a straight wire, and by pointing the thumb in the direction of the current, the fingers will give the direction of the field lines. Suppose we have a setup like this where a circular loop is placed through two holes in the plank and are connected to a battery. The current will start moving in this direction. Here also, you can consider each small part of the wire as almost a straight line and find the magnetic field direction using the right hand rule. So, for this part where the current is in this direction, the magnetic field lines will be circular like this. Similarly, you can move your right hand along the circular loop to get the magnetic field lines at various points. If you notice, at the two sides of the loop, the magnetic field circles are in different directions. The left is anti-clockwise while the right is clockwise. But let's look at the situation within the loop. You can see that all the field lines for each point in the wire are in the same direction and add to each other. This increases the strength of the magnetic field inside the loop. So, the magnetic field within the wire is in the same direction. Similarly, if we reverse the direction of the current, using the right hand rule, we can see that the directions of the magnetic fields at each point also get reversed. Also, within the loop, the magnetic field lines now move in the opposite direction. Now, if we look at this circular loop as a whole with some current flowing and ask ourselves what is the direction of the field in the center, we can find it by using another version of the right hand rule. In fact, we need to just reverse it. So here, if the fingers represent the direction of the current in the circular loop, then your thumb will give the direction of the magnetic field. So, in this case, direction of B at the center is this, while the direction is opposite when the current is reversed. So friends, in this video, we looked at the magnetic field in a current carrying circular coil. We also learned how to find the direction of the magnetic field using a different version of the right hand rule. Till next time, happy learning!